All right, here's a couple of good stoichiometry questions. Um, First one says you mix 40 mils of potassium chromate with silver nitrate, and they say what mass of solid forms? Oh, well, let's write our formula. K2CrO4 plus silver nitrate, AgNO3, yields, double replacement reaction. So potassium goes with the nitrate, KNO3 plus silver goes with the chromate. Now chromate's got to be a 2 minus. If you look on the chart, I think it's a 2 minus, and silver's a 1 plus. So it would be Ag2CrO4. Is that right? Yeah, I think that's right. Okay, so now let's balance. 2 potassiums here, so I'll put a 2 potassiums, but that gives us 2 nitrates, so I'll put a 2 here to give me my 2 nitrates, but that also gives me 2 silvers, which I have already, 1 chromate, unbalanced. So 1 to 2 to 2 to 1. Okay, so they say 40 mils of potassium chromate, so my volume here is 0.040 liters, and my concentration is 0.226 moles per liter. And then they say, and they mix that with 40.0, let's do liters, 0.040 liters, and, the concentration is exactly the same. 0.226 moles per liter. They're giving me too much information. So what this must be is a limiting reagent question. And then they say what mass of solid forms. Well, I don't know if this one's a solid or if this one's a solid. So what I can do is I can look over into my solubility chart and just see. So potassium and nitrate. So nitrate, where's nitrate? Oh, right there. And nitrate goes with potassium. Potassium not here, therefore it must be here, and this is the aqueous line. So this one's aqueous, so it's not the solid, so it has to be this one. This one has to be the solid. But I don't see a chromate at the top here. There's a chlorate, but no chromate. So I'm going to have to, I guess, just guess that. You could maybe look it up online. On a test, I would either get one that's from this chart, or I would tell you which one. So we're looking for the mass of this silver chromate. So now I've got a problem here. Not a problem, but my challenge is I've got too much information. And so this must be a limiting reaction question. So to do those, what you need to do is figure out the moles of each of these, and then compare the mole ratio and just see which one's going to be the limiting reagent. Now, if you take a look at this, both of these moles are going to be the same. Let me not use logic on you just to figure it out. Let's figure out the way we would usually do it. So usually the way we do it is we'd figure out the moles of potassium chromate. So that would be moles is equal to mass. Oh no, these are volumes. So not that. It would be concentration is equal to moles over volume. So moles are equal to C times V. So if I multiply the concentration, 0.226 moles per liter, times the volume, 0.040 liters, then the number of moles are, calculator, what am I doing, 0.226 times 0.04, ooh, very small number, 0.00904 moles. Okay, now let's figure out the moles of the other one. So the moles of silver nitrate I'm going to do the same thing. And it's going to be the same number, right? Because I have the same concentration, same volume. So its number of moles are going to be exactly the same. So now I have to figure out which one is going to get used up first. Often I like to say, okay, which one do I have too much of? And the one that I have too much of, the other one is going to be the limiting reagent. Or you can do something like this. Let's take this first one. So let's take this one. So, and let's use the mole ratio to see how much of the silver nitrate we need. So if I have 0.00904 moles of potassium chromate, then I would need, according to the mole ratio up here, 1 mole K2CrO4 reacts with 2 moles of silver nitrate. So these cancel, so I times it by 2, so that'll be 0.01808, I think, moles of silver nitrate. So my logic here is, if I have this many moles of potassium chromate, I need this many moles of silver nitrate. But when I look, I only have that many moles. I don't have enough. Therefore, this one, the silver nitrate, this is the one here that is my limiting reagent. I don't have enough of it. I've got plenty of this. When the reaction happens, I'm going to have excess of this. There'll be stuff of this left over, but this one, it'll get all used up. Okay, so that's my limiting reagent. So this is the one that I'll use my stoichiometry with. So let's do stoichiometry. So I'm going from a concentration, I have to go to moles, and then moles ratio to the other side, and then they want to know mass, so that'll be up here in Solidsville, or Solidsdale, whatever. Anyway, 3 steps. 1 step, 2 step, 3 step. So first I have to figure out moles of silver nitrate. I did that right there. So that's step number 1. Now I need to get across the river, so let me go down a bit. Different color. So to get across the river, I take, these are my moles of silver nitrate that I have. And to get across a river, I'm looking for moles of this one. And it's a 1. So 1 mole of silver chromate gets formed from 2 moles of silver nitrate. Okay, moles of nitrate cancel out. So I divide this by 2, so it'll be 0.00452, I think, moles of silver chromate. Okay, so I'm right there. Now my last step will convert that to a solid. So I need to take the moles of silver chromate and convert that to mass of silver chromate. That's what I'm doing at this step. Okay, so formula for doing that is moles is equal to mass over molar mass. I'm looking for mass, so this formula would change to moles equal to mole times molar mass. The moles I have right there, 0.00452 moles. You know, I'm second guessing myself. I did that in my head. Let's see if that's right. Did I do that right? Yeah. Whoops. Okay. 0.00904 divided by 2. Oh, I typed it in wrong. 0.00904. Yeah, that's right. Yeah. Okay, so that's how many moles multiplied by the molar mass of silver chromate. Okay, so silver. I've got 2 silvers, and I have 1 chromate, and I have 4 oxygens. So the oxygen is 64 even. I'm going to have to look up the others just a sec. Okay, molar mass is this one, 331.74. So 331.74 grams per mole. Okay, so I have that on my calculator. Whoops. 0.00452 times 331.74. 1.49 something. So this is equal to 1.4994648 grams. Moles cancel. Sig figs, 3 everywhere. So I would have to round that to 1.50 grams. Okay, perfect. So I would pick that one. That's a tough question. Doing the which is the limiting reagent first, and being able to recognize what that is. And also the tough part is this one here, is figuring out which one is a solid and which one is aqueous. Yeah, good question. Here's another. So I mix 100 mils of a 0.1 mole solution of sodium hydroxide, 150 of that of HCl, and determine the concentration of H plus in the final mixture after the reaction is complete. Ooh, that looks like a, limiting reagent question too. So let's write our reaction down first. So I have sodium hydroxide plus HCl, and that double replacement reaction, so sodium chloride plus HOH. Okay. Interesting. So in just looking at it, if they say determine the concentration of H plus in the final mixture, what they're going to do is and I'm just throwing out numbers, but it's like I've got 10 of these and 11 of these, and when they react, it's 1 to 1. I think this is all balanced. So it's 1 to 1. Oh, let me put a different number here, 19. So it's 1 to 1, so 11 of these can react with 11 of those. So if you subtract these, you have 8 left over. And from that 8, I'm going to get the concentration. That's a tougher question. I like it. Okay, so let's figure out moles for each one of them. Okay, so sodium hydroxide, my volume is 0.100 liters. My concentration is 0.100 moles per liter. HCl, I've got volume of 0.150 liters, and I have a concentration of 0.104 moles per liter. Okay, so to figure out which is the limiting reagent, I need to figure out how many moles each of those have. So moles of NaOH, to get that, my formula is C equals N over V because it's a liquid solution thing. So to get the moles, I've got to multiply both sides by V. So moles are equal to C times V. So my concentration is 0.100 moles per liter, and my volume is 0.100 liters. The liters cancel when I multiply that 0.01 moles. So that's how many moles of NaOH I have. Okay, so now let's figure out how many moles of HCl I have. Same formula, right? So moles are going to be equal to C times V. Concentration is 0.104 moles per liter, and the volume 0.150 liters. Liters cancel. Let's multiply. 0.104 times 0.150, 0.0156, 0.0156 moles. Okay, so this is what I'm looking at. So since it's a 1-to-1 relationship, for every mole of sodium hydroxide, I need a mole of hydrochloric acid. So basically, I'm just going to take these two and subtract them. And it looks like this number is the larger one than this. So this one will be my limiting reagent, but this is the one that I'm going to focus on this time because I've got the extra. And then I'm going to use just the concentration formula to figure out what the concentration of that is. Notice that I'm thinking HCl and H+. I'm treating those as the same because HCl is the acid. It's the thing that gives me hydrogen ions. So I'm thinking of them as being the same. So let's subtract. So the number of moles of HCl left in the solution will be 0.0156 minus 0.01 moles. And so when you subtract those, I think that gives you 0.0056 moles. Is that right? Yeah, I think so. Okay, and that's moles of HCl, or I'm saying that that's the same as moles of hydrogen ions. Because HCl, if you remember our dissociation, dissociates into hydrogen ions and chloride ions, and it's 1-to-1-to-1. So if I have this many moles of HCl, I have that many moles of hydrogen ions too. Okay, and so they want to know what the concentration of hydrogen ions are. So the concentration is equal to moles over volume, moles 0.0056 moles, divided by the volume. Now here you have to be careful because you've dumped these in together. And so you don't just have this volume of HCl, you've got this volume of NaOH there too. So your total volume is going to be 0.250 liters. Okay, so let's divide those. 0.0056 divide 0.250, 0.0224, 0.224 moles per liter. Sig figs, I got 4, 3, 3, 4, so I got to go to 3. I've got 3. That's good. Is that the answer there? Right there. Good. Okay, that's a difficult question because it's not really stoichiometry. It's more thinking about what you have and how things react. I thought it was going to be a limiting reagent question, but they didn't ask for any information over on this side. They just wanted me to focus on that side. Okay, hopefully that helped clear up those two questions for you.